Okay, let's go over a few classwork problems using G-Power to get you ready for the homework problems. So let's start with the first question or problem here. We wish to conduct an intervention study for preschoolers' gross motor skills. And again, examples here: run, jump, skip, throw, catch. In the intervention, we will teach children how to perform the skills. We plan to measure children's motor skills before and after the intervention in the hopes that the intervention increases motor skills. And so I'm going to highlight that because that sentence gives us a lot of information about what we're going to need. And then previous motor intervention studies have shown a large effect on children's motor skills. Okay, so assuming a significance level of 0.05, what sample size do we need to achieve 80% power? All right, and you'll see over here on the left side of my screen, I've got G-Power up. And the first thing we need to do is go to Test Family and decide what kind of test do we have here. So we've got gross motor skills in preschoolers, and we have before and after the intervention. So there's the two groups, the before and the after, and our continuous dependent variable would be this motor skill measure. So this would be a t-test. And when we look at our options under the statistical test, we'd want to go down here to means, either difference between two dependent means or matched pairs, or the independent means. So what do you think is here? So again, we've got this before and after. So we're measuring the children before the intervention, and then we do the intervention and we go back to them after the intervention and measure them again. So this would be matched pairs. All right, and moving down into our input parameters. All right, so we need to decide if this is a one-tailed or two-tailed test. And notice in the highlighted sentence, we hope the intervention increases motor skills, right? So we're going to test, that before motor skills are less than after motor skills. All right, and with the effect size, we've used this intervention a bunch of times, and the previous studies with this intervention have always shown a large effect. So we would need to change our effect here to 0.8. All right, and in the problem, it says to assume a significance level of 0.05, so alpha stays 0.05. And it says, let's go with our rule of thumb of 80% power. So we need to change our power to 80%. And then we can click calculate. All right, and what do we get? We get a sample size of 12 students. All right, so I can put in here 12 as our sample size needed for 80% power. But as we've talked about, 80% power might not sound that great to us, right? So in question 1, part B, what happens to the sample size if we want to achieve 95% power? So let's go in here to our power and change this to 0.95. Do you think that the sample size is going to increase or decrease? And hopefully after the lecture, you're thinking that we're going to need more preschoolers. And you're right, going up to 95% power, we would now need 19 children in our study. All right, what if we want that 95% power, but also want to err on the side of caution by only assuming a medium effect size? So if we assume a smaller difference, right? So we go in here to our effect size, which right now, and again, I can show, you may want to keep this table on hand as you work through the classwork and the homework. So I'm referring to this Cohen's d table here. So large was 0.8. All right, and if we want to decrease to medium, so we're decreasing to 0.5. So I'm going in here and changing this to 0.5. All right, so that smaller difference, what do you think is going to happen to the sample size we need? And hopefully you're thinking that that sample size is going to get bigger, and it does. So now it increases, so I'm going to say increases to 45. So smaller difference requires larger sample sizes. All right, now let's go to question 2. We wish to determine if socioeconomic status, or SES, is associated with 10th grade math scores. We will collect SES quartile data for each student, where 1 would be students in the lowest 25% in terms of socioeconomic level, all the way up to 4, which would signify the top 25% in terms of socioeconomic status. All right, and just as a reminder, I want to take a pause here and go over to JASP, especially for those who may not be familiar with it. So here I have JASP up, and I just want to, have you remember, how do we get effect sizes in JASP. So let's go to, I want to open a data file that's on my computer. All right, so I'm going to go to my desktop, and I'm going to scroll down to where it is. And this is some data we're going to be working with through a few lectures. This is from the Educational Longitudinal Study, and it's high schoolers. And so here we've got student ID, sex. This is an instrumental motivation like interest and utility. Geographic locale, so this is going to go from 1 urban, 2 suburban, 3 rural. We have math self-efficacy, so kind of how confident they feel in math. And then we have math achievement scores in 9th grade, and these are all 9th grade measures. We have that SES quartile, and we have a race variable that has been a little bit abbreviated from the original data set into 4 categories. Okay, so let's go to just with this. So we're thinking about this problem of SES quartile on 10th grade math achievement. So let's say we're actually going to run it, and this is a very large data set of, I believe, 18,000. So we put in math achievement as the dependent variable, and we have SES as our fixed effect. All right, and so we've got these 4 quartiles. And if we go down here to display, we want to display eta squared, okay? And we see here that eta squared is 0.177. And recall from the lecture that if we want to get to Cohen's F, which notice here, I guess we will see in a minute in G-Power where G-Power asks for Cohen's F related to an ANOVA. But we have, an eta squared, and oftentimes we may see eta squareds in our review of the literature. So let's go to Excel. All right, my handy dandy calculator. All right, and I'm going to get a blank spreadsheet here. All right, and let's calculate our Cohen's F based on an eta squared of 0.177. So I'm going to say equals square root of eta squared, 0.177, divided by, and I need to put in parentheses because Excel knows order of operations, 1 minus eta squared, 0.177. And then I close the square root parentheses, and I get a Cohen's F of 0.46. Okay, so and 0.46 would correspond to a large effect size. And so what that's saying in JASP, in this particular example, is that SES has a large effect on math achievement in 9th grade students across the U.S. Okay, so again, I just wanted to review eta squared just a little bit and how we can use eta squared to get to Cohen's F. Okay, so let's go back now to our problem 2, and we want to to know if SES is associated with math scores. So first and foremost, we've got these 4 quartiles, right? The 4 groups, and we've got this continuous dependent variable of 10th grade math achievement. So when we go to test family, is this going to be a t-test or is this going to be an ANOVA? And hopefully, because you see 4 quartiles, you are thinking an ANOVA, and that's an f-test. All right, and when we go over to the statistical tests, we've got a few ANOVA options here, okay? And really we're needing to decide between the fixed effects omnibus one way or the fixed effects with special main effects and interactions. So here we are just interested in the fixed effects omnibus one way, all right? So that means we've got one predictor that with more than 2 categories, which is SES. And the omnibus test is, and if I go back to JASP for a second, this is the omnibus test. So we're not comparing quartiles with one another. Remember in ANOVA speak with the alternative hypothesis, this significant p-value is saying that at least one SES quartile is different from another, from the others. Okay. All right, and so we've got our fixed effects omnibus one way, and you see down here now we need an effect size F. And this is telling us large national studies have shown a large effect size for SES. We kind of just showed that with our ELS data as well. So a large CONF would be 0.4. And we've got alpha 0.05. We're starting with the rule of thumb of 80% power. All right, and number of groups would be how many groups or categories do you have in your categorical variable. So with SES, we've divided it into quartiles, so we have 4 quartiles. All right, and when we calculate this, we see that we need 76 students to achieve 80% power. But again, you know, we may not be happy with 80% power. We may want to bump this up to 90% power. So if we change this to 90% power and calculate, all right, that means we need to go up to 96 students in our sample. But notice, even across 4 quartiles, we're not needing that many students. And the reason is we are kind of banking on that large effect, right? But what if we want 95% power? So I'm going to change my power to 95%. And we want to err on the side of caution by only assuming a small effect size. So let's go back to the PowerPoint for a second. And we see a small effect size is 0.10. So if we change this effect size F to 0.10, what do you think is going to happen to our sample size? So we've gone up in power and we've gone down in effect, and we see now, wow, big difference here, right? Now we need 1,724 students across the 4 quartiles. All right, so let's go into question 3 here. We wish to conduct an intervention study for preschoolers' gross motor skills again. In the intervention, we will teach children how to perform the skills. We plan to have a control group of children who do not receive the intervention, and we expect the intervention group to have greater motor skills at the end of the study. Previous motor intervention studies have shown a medium effect on children's motor skills in this situation where we're comparing a treatment and a control group. All right, so again, we've got this continuous dependent variable of gross motor skills. And now we have 2 groups, a control group and an intervention group. So we go to our test family and we change this to a t-test. And now we have 2 independent groups. They're not matched, they are independent. The control group is independent from the intervention group. All right, we are looking at motor skills, right, that are going to be greater in the intervention group. So here I'm going to highlight, we expect the intervention group to have greater motor skills at the end of the study. So this is a one-tailed test. All right, our effect size, this says to assume a medium effect. And if you haven't memorized them yet, let's go back to the PowerPoint and look at Cohen's d for t-test, and medium is 0.5. All right, so I can leave it on the default of 0.5. We're keeping alpha at 0.05. And in this first question, we are going with the general rule of thumb of 80% power. And in this situation, we're going to have balanced groups. So we're going to assume a ratio of 1 to 1 in terms of intervention and control groups. All right, and so we calculate this and we see that we need 102 children total, where we would need 51 in each group. Now, if we want to increase that power to 95%, that sample size we know at this point is going to go up, and it increases to 176 children, where now we need 88 children in each group. All right, and if we want to keep that 95% power, but err on the side of caution by assuming a small effect size, all right, and again, small effect size takes us down to 0.2 for Cohen's d. So if we change this to 0.2 and calculate, we now see that we need 1,084 children, or 542 children in each group. So our study gets, monumentally harder in terms of sampling, the smaller that effect size that we assume. All right, well, hopefully this sets you up for the homework. If you have any questions, reach out to me.